Let's start by saying that waves are very important and contribute to all our senses, such as why we see and why we can hear. Waves are also the reason why we can play the radio in our car and so much more. But what are waves exactly and how does it work? Waves, like the name suggests, can be thought of as a one-dimensional wave. You can imagine a wave as a particle that moves up and down symmetrically. There are debates whether waves are actually particles, but it is easier to grasp it in this way. The energy of the wave depends both on its amplitude and frequency. Wavelength is directly related to the frequency, as shown here. Wavelength gives the length between two identical points on the wave. Amplitude is the height of the wave from the origin. In our car, we can set the radio either to stations with an FM in the front or AM, and this both points us in the direction on how waves are processed. The information is stored in the energy of the wave, reading it either from the frequency, called frequency modulation, or amplitude modulation. Both have pros and cons. FM is desirable when transmitting more clean sounds, while AM has a lower bandwidth and can accommodate more stations. In your car, there is a detector, a receiver, that senses the waves from the air and changes their form to be played in your car. The waves are generated by a sender of these signals, a radio tower, for example. There, the data is encoded on wave signals, which are then sent out for other receivers to pick up. So that is for the radio. The exact same thing happens in our phones. Our phones has an antenna which detects the waves. These waves are increased and processed by electrical circuit and delivered to us as voices when someone is calling you, or the Wi-Fi, wireless networking. When the waves have been processed by a circuit and transmitted from our radio, they are changed into sound waves. Our ear senses these sound waves with a membrane and other parts of the ear, which in the end changes these signals to electrical signal that is carried to our brain for processing the information. It's important to note that waves that is sent between the radio towers and the Wi-Fi are radio waves. They are not high energy, so they should not cause any damage, but they are also not visible. The sound waves are mechanical waves, which require a presence of a material medium to be able to transfer its energy from one location to another. These waves have the frequency of 20 Hz up to 20,000 Hz, which are the frequencies our ears can process. Dogs, for example, are able to detect frequencies up to 45,000 Hz and cats up to 79,000 Hz. This means that they hear things that we are deaf to, such as silent devices, as they still give out certain energy. That's why dogs and cats can greatly benefit when we turn off all lights and plug out our TVs when they are not in use. But how does this then relate to our eyesight? In the video about electromagnetic field, I discussed how electromagnetic radiation was carried from space and part travels through our atmosphere. When it is there, it is reflected off everything on Earth. What this process means is that the objects they hit either absorb, reflect, or transmit certain frequencies. This also means that an object might reflect green light while absorbing other frequencies. This depends on the frequency and nature of the atoms of the object. Humans can only detect a certain range in the electromagnetic spectrum, from 400 nanometers to 700 nanometers. Depending on this radiation, the photoreceptors in our eyes detect these waves and change them to electrical signals that travel to our brain and give us vision. And as an example, why is the sky blue? Or why is the space black? When the sun is shining onto Earth, light gives the molecules in our atmosphere a certain amount of energy. A process then causes the electromagnetic radiation to be scattered in all directions. The reason why the sky is blue is because the reflected radiation is in the blue visible light spectrum. When there are clouds in the sky, their energy reflected is different, causing another color of light. When the sun is not facing our Earth, there is not enough waves for atoms to reflect electromagnetic radiation, and our eyes cannot detect this, giving the color black.